Welcome to Morpheus-Chair, the program where you learn how to build real robots like this one's from your comfy chairs. In this program, we're going to learn how to build a robot from scratch, this robot that we have here. And for that, we have to talk about the most important part of robotics projects, which is having a concise idea, a very precise idea of what you want to accomplish. So I always say that in any engineering project that you try to start, it's really important that you have clear idea of what you want to accomplish. This is really important in robotics because normally, and I myself I've done it, that I say, hey, I want to build this robot that talks and walks like that and so, and it's like a human. With these very vague ideas, the only thing that you will have is problems, a lot of unexpected errors, and at the end, discouragement. And that's something that we don't want, because I want you to learn how to build robots to enjoy it. So to do it, you have to finish your project. And for that, you have to have clear objectives. Don't try to get the moon. Just try to get a tiny stone, and then a bigger one, then a bigger one, and at the end, you'll get the moon. So, what's our objective in this video series? I want to build a robot that allows us to learn as much as robotics as possible about the basics of robotics. This is one. Another one is that it has to be very cheap, the cheapest as possible, because we are learning, so it makes no sense to spend a lot of money in something if you're learning. So cheap, make it cheap. And what's the objective of the robot? I want a robot that can follow a line on the floor made by sticking electrical tape of different colors in an indoor environment. So in my house, in my room, in my office, that's the objective. With this really simple objective, what we accomplish is to set the foundations to afterwards try more risky stuff. It also allows us to learn all the details of our technical system and know how everything works and moves and stuff. For afterwards, being able to do more complex stuff, it will have unexpected errors, but because we know our hardware and we know our systems, we will succeed. So, what we will need to build this nice robot. So, I'm going to talk about the materials in general that we will need. So, let's get started. The first thing is we need our robot to move forwards, backwards, left and right to be able to follow a line. So, we could do this in many ways. Very strange locomotion systems like legs and flying, but we have to keep it simple. And what's more simple than two simple wheels and an omni wheel here? That's it. We have 3 points of contact on the floor, so it's stable, and we can move around left and right, forwards and backwards. It's more than enough. The next step is, how do we move those wheels? We need motors. So we will select very basic DC motors. They are cheap, they are simple to control, and you don't need anything else. Then next thing is, okay, we need a power supply to move these motors. So we will use just battery packs, very simple. Then we also need some kind of sensor to see the line that we want to follow. So we will use a camera, an RGB camera. It's versatile. It will allow us to build a robot that then afterwards we can do navigation with cameras. I know someone would say, hey, you can do this with following line sensors and it's much cheaper and it's much easier. Yeah, it is much easier and maybe cheaper. But the problem is that I only can use that for following lines. If I don't want to follow lines, then what will I do with that sensor? It's useless. So it's, in my opinion, it's much more robust having a camera. You can do loads of stuff with the camera, and we will learn loads of stuff with that. With a following line sensor, you'll only learn how to follow lines. That's it. Okay, then we also need a power supply for, then we will need some kind of brain computer to power and move all this. And for that, we are going to use a Raspberry Pi number 3 Model B, and that's it basically. We will use also a hat for controlling the DC motors through a simple H bridge, and finally we will need an independent power supply for our Raspberry Pi, because we want to be able to test things in the Raspberry Pi and program directly in the Raspberry Pi without having to power the DC motors. And basically DC motors have different power requirements that Raspberry Pi doesn't have, so you need an independent power supply. The fewer components you have, the easier will be to spot and detect the errors and know where they are. If you have like 20 components chained, it's really difficult to debug. That's one. And the second is cheap. Cheap because you'll be breaking stuff. Maybe you'll select, I don't know, an RGB, and you'll see that maybe you need something else. If you spent hundreds of dollars in a sensor and you have to change it, whoa, that's discouraging. So keep it really, really cheap. Cheap and simple. That's my advice. So if everything goes well, you should have something like this. As you can see, it's basically a robot following a yellow line. That's it, nothing fancy. So enough talking. You'll find in the description below the list of all the materials that you'll need for this session and for the following 1 or 2 sessions more. A total disclaimer, we don't get paid for this. It's just to make your life easier to find all the elements that you'll need to make this work. And without further ado, to the workbench, to the workbench, to the workbench, to the workbench, to the workbench.
So the first step is to get all the needed components organized in your workspace. I highly recommend you to have some kind of working mat like the one I use here. I've left the link in the video description. It is very useful to keep your space organized because, for example, it has magnetic spaces for your screws and stuff that they stay organized and in place. It's also welding proof, so good for that. And also for electronics, it's very neat feature to have. So please consider having one of these. So here are all the elements we will need for today's build. So as you can see, we have the wheels, we have the DC motors, we have some components for the DC motors, the structure, the screws we'll need, the Omni wheel, and also we have the battery pack here and the tools that we will need. Okay, so basically we will need just some old simple pliers that they are just to get the screws in some difficult places, and a screwdriver like this one. Yeah? Okay, perfect. The first step will be to place the speedboard holder onto each DC motor. So these wheels could be used afterwards for speed control. These DC motors are just regular old DC motors with a gearbox here to reduce the speed of rotation, because the output of DC motors is normally really high, so we have to lower it. We now get the chassis button, which is this one here, and add the support for the motors. We have 2 for each of the DC motors, so it's really simple. Slide this one's here, one here, on the other one here. There you go. And now you slide this one here and that one here. Yeah, okay. And now we have to use these M3 screws of 30 millimeters in length, yeah, to screw these DC motors. If you have a look, you see that you have some holes here where you will place the screws through, and this will go through these supports and get everything in place. So let's go. Be sure to place the cables through this hole here. It will make it much easier afterwards. We continue with the second DC motor. Bear in mind that these discs have to go through this holes, so be sure to move it until it doesn't hit to anything, otherwise you'll have problems to mounting it. So be sure to put the 2 screws. This one, it's a bit more difficult, so you just have to press with your finger and then screw it with. Now we go to the next DC motor. We do exactly the same thing. Okay, and there you have it. So now the problems that you will have is probably getting these screws here, which are quite tricky. Use some pliers. So here we have the DC motors mounted into the bottom part. The most difficult part will be the bolts, because you'll need some pliers to grab them so that you can stay there and then screw it through the other side. Also, if it doesn't fit exactly, the best recommendation is that you don't turn all the way. So leave it a bit loose, and that way you'll be able to put the 2 screws there. Okay. So there you have it. So we have our bottom part mounted. Now we can add the wheels. Just align the wheel notches with the motor notches and press. Now we can mount the Omni wheel with the 2 L25, which is the spacers here. These spacers, we can use these spacers to mount the Omni wheel. So we are going to mount the wheels and the Omni wheel. Yeah, so let's get started. Now for the Omni wheel, we have to place the spacers in the correct holes. So the correct holes are these ones that you see here. This one and this one. So we can check here. So you see it exactly fits inside these two holes. Let me make a close-up here. So these two holes are the ones that we have to put the spacers L25 inside. I suppose that it's L25 because it's 25 millimeters. Okay, so we unscrew this and we get the screws through the holes, and there you go. So now we turn them, pressing on the other side with my finger so that it doesn't go loose. There you go. First one and the second one. There you go. So now we just have to place this here. Easy. So the tricky part was really the DC motors. Now this is sturdy and we turn it around. There we go. So now we check that it's working, it's moving around. Perfect. Now the next step is to attach the battery pack onto the robot. For that, we have to use 2M3 6mm flathead screwed onto these two holes that we have here, there. I don't know if you can see it. There you go, 1 and 2. There you go. So we go to our space here, and there we have it. So that's why it's really neat to have this. So we place them just like that. Let me center this more, like there. Okay. So you have to place them on these two holes. As you can see, if you need, because it's really tight, you have to press on the screw with your screwdriver so that it gets in. Otherwise you'll have some problems there. Okay, so obviously this is not bolted, so we need our bolts. And there you go. So the most difficult part is this bolt here. It's really tight. So the best recommendation I can give you is to press with your finger on the bolt until you feel that it's inside, just inside, and then press, and then go with your screwdriver and screw. And you will feel with your finger that the screw is going through. Okay, fantastic. Now we have to add the L25 spacers. For that, we go here and we fetch the spacers that we need to put the top part here. Okay, there we go. So now that we have everything set up, let's start. So what's the best way to do this? Well, you can see that the bottom part has these grooves here. They're not very precise, so it's maybe confusing to where exactly do you have to put them, but the top part has very specific holes where to put it. So what we're going to do is bolt first the top part, and then we're going to bolt the lower part. This way it will be much easier and much faster. So let's go. Okay, and there you are. So these are the 5 holes where you have to screw the screws. So now we lift it, and one by one we press them and we screw them. And there we have it. So now we have the spacers in the correct places. So now we just have to flip it around like that, bring the other bottom part and marry them. And now we know exactly where we should put the screws. Yeah. So as you can see in this bottom part, they'll have to be set here, 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 and then this one here. So the only conflicting ones were these ones. So let's go. I always recommend that you bolt diagonally opposed screws so that you fix the structure, and once you have it, then it's much easier. So there we have it. The only details that we need to address is the fact that we have these cables here that will be connected to the Raspberry Pi. So we can put them to one side or just leave them here, just because we will probably have to unmount this panel, top panel, to get these cables through. But depends on where we put the Raspberry Pi. And there you go. So now we have our simple robot structure mounted. Fantastic. It wasn't that bad.
Whoop! Whoa. We're back here. So it's enough for today. So please leave in the comments below all the results of your build. If there was something that didn't work, something that you improved, please leave it in the comments below. In the next video, we're going to give this little bad boy a brain. Raspberry Pi, the camera, program the Raspberry Pi, and make this boy move. Until then, keep building, keep building, keep building, keep building, keep building, keep building. Keep building. The most basic way of doing it is with simple wheels.